In this paper, we present a modular framework for adaptive agent-based steering. Despite many great contributions in steering research, state-of-the-art applications still have problems with steering. To address this, we propose using multiple steering techniques in a single framework, including reactive and crowd-based steering, predictive steering, and space-time planning. For basic steering, the agent reacts using short feelers, computes a path to its goal, chooses a local target along its path, and moves dynamically using forces. Locomotion constrains these forces so that the agent can only move like a pedestrian. Predictive steering uses space-time collision prediction and often needs only subtle steering changes to avoid threats. These examples illustrate how subtle but important predictive steering can be for natural behaviors. We solve challenging local agent interactions using a novel space-time planner. The space-time planner uses A* and a novel cost function to search for an efficient trajectory in the space-time domain. Agents invoke space-time planning only when needed and seamlessly transition in and out of the space-time path. To improve performance, we update each phase at its own frequency. We then explore how far we can reduce the frequency for each phase, a technique we call phase decimation. Reactions are generally updated 20 times per second, but predictions can be reduced to 3 or 4 updates per second. Perceptions in short-term planning are more costly to update, but they can be updated even less frequently, usually less than once per second. This allows us to use computationally expensive methods, such as perceptions and short-term planning, to steer naturally, yet keep low latency fast reactions. Adaptively decimating phases allows the agent to increase or decrease the frequency of updates based on its current situation. This way, steering is robust and still has a small amortized cost. The rest of the video uses only adaptive decimation. The framework is capable of handling dense crowds of agents in real time. Note that the choppy effects are because of unblended animations. The agents are not oscillating. Bottleneck scenarios with hard corners are particularly challenging because all agents must steer towards the middle of the doorway before proceeding through. This forces agents to interact in a variety of configurations at the bottleneck, such as crossing, oncoming, or more complicated situations. In each case, the agents must intelligently interpret whether they should proceed or let the other agent pass. In some cases, the agents need to recognize that they can steer normally despite the crowded conditions. Predictive steering, reactive steering, and crowd-based steering are all used and necessary for agents to successfully sift through bottlenecks.